Wow, I'm getting tired. that was taking that was taking a minute there. All right, so at least we got one of them done. So all right, but anyway, so suppose I have a lens that has a 48.5 millimeter focal length that is being used to photograph a flower. Well, that's going to be our converging lens. Okay, so that focal length is positive, and and so and the flower is 77.5 centimeters away. All right, what distance in millimeters must the camera see? Okay, so let's convert that centimeters to millimeters. 775 millimeters away. Now let's keep everything in millimeters so we can do this problem. All right, we need the distance of the object, and then what I'm going to add to that, since this is a converging lens. We're going to add the magnification. What's the magnification and all that. So here we go. Let's take a peek at this. All right. Sorry, I got distracted there for a second. Should have my phone off. Where the hell do I go? See, I've lost it. Okay. Oh, let me look at the problem one more time. Distance to the object. So this is a converging lens problem. And I just can't find an expert here. I just can't find decent problems for this stuff. That are kind of like rudimentary. They're great for the eyeball when we do that. When I get to that in the next portion. So I've got the we're going to leave it. The focal length f is positive because it's a converging lens. 48.5. Did you see the little note from my wife there? It's nice. Talking about what we're going to have for supper. Leftovers, which sounds fine to me. And we need to find DI. Well, there's nothing hard about this if we know DO is equal to 775 millimeters. So this is a piece of cake. We want to find DI. All right, so 1 over F is equal to 1 over DO plus 1 over DI. And the distance of the image is going to be a real image because I bet you this distance of the image comes out to be negative because we've got 1 over 48.5, which is much larger than 1 over 775. Okay, and then this equals 1 over DI. Then you just take this and flip it over, and you get what DI is. Then the magnification, again, same magnification. Negative. I always put the negative like this of DI over DO. And I bet you that sucker comes out to be inverted. Let's work that out. Jesus H. Christ. Oh, sorry. I'm terrible. -1. There it is. 51.7. It's 51.7 millimeters. And so therefore the magnification is equal to the negative, and that was positive, number. So it's 51.7 over 775. It's much smaller. So it's inverted and it's reduced. It's 0.006 is the magnification, or 0.007. It's really small. Taking it's about 6/1000ths. It's the size. All right, inside the camera, on the film. So if I take that number and multiply it by the height of the object, let's say the object is a meter high, it's going to be 6 millimeters high inside the camera. Seems on the film. Seems to make sense, right? Okay. I wonder if they have a better lens problem. Here. Okay, you can bring that. Here's, okay, so the standing, yeah, from a camera, the camera uses a focal length of 0.5 millimeter, which is about what we had, 0.5 meters. Yeah. There we go. This is a little more realistic type problem for a camera lens. All right? Good. I'm done. I am, put a fork in me. I'm finished.